let me just also, can I come back to another point? So you mentioned about like when we see galaxies around us moving apart, etc., right? So and you're saying, oh, people will say, oh, they're not really moving away. It's space is expanding between us, okay, and those galaxies. Now, one of the things I can do in relativity, which is one of the key things I can do, is I can change my coordinate system, right? Because coordinate systems are things that we invent, right? So I can take my little patch of the universe here, and I can either write down what's my cosmological equations, the Friedman-Robertson, Friedman-Lamatra-Robertson-Walker metric, which has expanding space in it. But I can do a coordinate transformation into static space and have objects moving instead. And I get exactly the same results by objects moving through space or the expansion of space in between. And what that shows you, of course, is, and this is one of the important lessons of relativity, is that no coordinate system is the correct coordinate system, because coordinate systems are things that we choose. But I can transform the coordinate system and I can have a different interpretation of what's going on and get all the same results. So yeah, if I talk about nearby galaxies, it's equally equivalent to talk about them as expanding space, carrying them away, or them moving away from me, which is why you can talk about Hubble's observations as a Doppler shift or a cosmological redshift.
So it seems like these two ways of looking at the expansion of space, whether space is somehow expanding, like the analogy of the raisin bread, or you can think of the galaxies themselves are moving away instead of the space itself expanding. Those are equivalent, it seems like what you're saying.
Yes.
But then that raises a question to me, which is, if I take that second interpretation, that the fact that I can look at it as if it's just the galaxies moving away rather than space expanding, it seems kind of coincidental that the further out that I look, the faster the galaxy would be receding away from me. Why should I expect that to happen? It seems like Hubble's law seems inexplicable under this particular interpretation. Whereas if I take the other interpretation of an expanding space, then there's an intuitive way to understand why that should work.
Oh no, you have to be careful there, right? Because there are a couple of pieces in play here. You've got your dynamical equations, right, which tell you how things are moving apart, but you've also got your initial conditions. And in your overall Hubble picture, right, you have the initial conditions that things are at rest with regards to expanding space, so these co-moving observers, etc. And therefore, I get that observations. In the other picture, you can just change the coordinate system, and in changing the coordinate system, you change the initial conditions, right? And I should point out that there are not just two, right? There are an infinite number of coordinate transformations I could make and get the same observations. By definition, changing your coordinates should not change your physics, but I get then different interpretations, different pictures in my mind of what is going on. But none of them is the right story, right? Because it's just a coordinate transformation.
So at the end of the day, these different pictures are ultimately related by coordinate transformations, and one can equivalently view the expansion of space from different perspectives, different coordinates, and depending perhaps on the problem, one could be more useful than the other. But yes, overall, it's not that there is one correct way of looking at the expansion of the universe. Rather, it's just they're all related by some coordinate transformations. Is that a right way of viewing the expansion of space?
That's effectively the right way of looking at it. I mean, there's a couple of small caveats in there. In that picture we talked about with galaxies moving away from us through static space, that coordinate transformation can only hold over a very limited volume in a normal cosmology, because you have to worry about the gravitational effects of all the other objects in the universe. So it's not a global transformation, it's a local transformation. because of the effects of gravity, right? But we know that. But there are people there are transformations you can do on a global scale.